Okay, so the next problem is a similar shapes and figures problem, which we did last 6 weeks. So you had your colored pencils. You want to make sure that you colored your corresponding sides. So we have 6 here corresponds to 15. And then 10 corresponds to A, or I like X, so we're going to put X there. All right, so let's set up our proportion, right? So 6 over 10 equals, and if I started with blue, I'd do blue first over here, 15 over X. You also could have done 6 over 15 if you wanted to do both blues, equals 10. And if you do this one first, you have to do it first again, over X. Either way, it's going to be the same. So 6x equals 15 times 10. So you just move your decimal one place. So I'm adding a 0. Divide by 6. Divide by 6. So I'm going to do 150 divided by 6. 2 times 6 is 12. Subtract, I get 3 or 30. 6 times 5 is 30. So I have that x equals 25. And that makes sense because 6 is a little more than half of 10, and 15 is a little more than half of 25. So that sounds good. 4 didn't make sense. It needs to be bigger than 15. So we found our answer. Okay, and last, we're not at the last one yet. We're down here to 14. So we have box plots. So it says the junior high principal collects data to determine how much time per week 7th and 8th grade students spent on homework. So which of the following best describes the shapes of the data distributions? Okay, so we always wanted to go ahead and analyze. So I'm going to do the range. So the range is the maximum, that looks like 11, minus the minimum, 1, so 10 here. The median is 7, we'll say. And then I see, let's see, skewed, symmetric, skewed. So we may not even need this information, but let's keep going. So range is 7 minus 2 is 5. And then the median is this middle line, so 5. Okay, now let's look. All right, so in looking at these, we want to look at where it is. So the median, if the median is pushed to the right, so that means that most of the data is here and up. So it's skewed the opposite way of most of the data. So if most of the data is to the right, then it would be skewed left. Here again, most of the data isn't halfway in the middle. It's mostly on this end. So this one's also skewed left. So let's read our answer choices. Distribution for the 7th grade data is skewed right and 8th grade is left. Well, I believe that they're both skewed in the same direction, so that's not true. The data distribution for them are symmetric. Well, no, they don't look symmetric because they're not a mirror image. C says the data distribution for 7th grade is skewed left, while 8th grade is skewed right. Well, they're both skewed the same direction. They both look about the same. So we're going to go with what we said, is that they're both skewed to the left. Okay, and finally down to the last problem. Here it says, Rick places green and red balls in a bag. I'm going to try to get this so we can see all of our answer choices. Sorry. Okay, so he has these in a bag. He picks 3 balls at random without putting them back. Okay, so without putting any back, what is the probability that all balls are green? Okay, so first of all, we have 1, 2, 3, 4 green. So we counted 4 green, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 total. And if you look here, since it doesn't want me to simplify, so I'm not going to simplify, but then it says without putting any back. Okay, so we took them out. We didn't put it back, so we took out a green one. So now there's how many green? 1, 2, 3 green. And we took one out, so the total went down by 1. Then the second one, we left that one out, so there's 2 green left. And my total went down to 8 again, or down again to 8. So I'm going to multiply those 3. So here, since it says without putting them back, I know I can eliminate B because the totals stay the same. Oh, C and D, they stay the same. So just by knowing, not even creating my probabilities, just by knowing that without putting them back, my total changes, I found my right answer of A.